Welcome back for our third day of solving these systems of equations algebraically. Today we're going to have two focuses. By the end of this video, you're going to be able to choose a method to solve. So I'm going to just present a problem to you and you'll get the choice to use substitution or elimination. And then we're going to dive into word problems. How can we use these to solve word problems? Now when it comes to choosing a method to solve, basically for substitution, what you're looking for is if one of the equations is already solved for. All right, if one of the equations is already solved for one of the variables, then that's kind of an indicator that substitution would be an easy method to solve it. Elimination, what you're looking for is both equations to already be in standard form. Again, you can always use either one. I'm trying to show you what's convenient, what's easy to use to solve, because a piece of your test will be me just giving you some equations and you'll have to pick a method. So let's take a look at this first one on the left-hand side. So what I'm noticing, one of my variables is already solved for. In that top equation, I already have y by itself. So that means that it's going to be easy if I use substitution rather than trying to use elimination. Recall for substitution, I put a box around what that variable equals. I box the other side because now I'm going to toss it into the other equation. Remember, for substitution, you rewrite the second equation. Oh, I'm sorry, that should be a 2. You rewrite that second equation using that first one. So I've made my substitution, now I just have to solve it. I'm going to distribute the 3. I'm going to combine my like terms. I'm going to scroll down a little bit. I'm going to add my 12. Now here, be careful. Negative 8 plus 12, that's going to give you a positive 4. Then I'm going to divide by 8. And again, what I want to remind you of is I try to be kind in these. I don't give you many nasty fractions, anything like that. But again, I need you to understand not all of these are going to be whole numbers. So there will come some times where you'll get something like 0.5. Okay, don't freak out. Don't think you've done something wrong. It can happen. So I have an x of 0.5. Now remember, once I get that, that's only half of my answer. I need an x and a y. So I put that back into the box. So 2 times 0.5 minus 4. So y is going to be 1 minus 4 or negative 3. So my solution is going to be 0.5, negative 3. So that's how we go about the substitution method. Now, let's go back up to do the right-hand one. Elimination is often easiest, again, when you're talking about things in standard form. Now, ideally, you want one of the variables to have the same coefficient in both equations, but the x doesn't have that, and the y doesn't have that yet. So remember, if they're not lining up right, remember all you have to do is take that 2, multiply it down here. Take the 1 that's right there, multiply it up here. Now, notice I'm not bringing the whole negative 1. You can if you want, but all that matters is the magnitude of it. All that matters is the 1 when you're flip-flopping those numbers. So remember, that's how you handle this. If they don't line up, you flip-flop those x values to multiply the other equation. So on top, well, nothing really changes. Multiplying by 1 doesn't change a thing. But here when I multiply by 2, I get that. All right. So let's take a look at what happens here. So I'm going to add these equations together because notice the 2x and the x, that's what lines up now. And if I add them together, that's what's going to allow me to eliminate them. That's why I didn't bring the sign with it, because it was already going to cancel nicely anyway. Whether or not I multiplied by that negative or not, it was already going to cancel for me. So 2x plus a negative 2x cancels out just like I want it to. Negative 2y plus 6y. Well, negative 2 plus 6 leaves me with 4. Negative 10 plus 38 leaves me with 28. So I divide by 4, and I get a y of 7. Again, I want you to recall, though, that that's not the end of our story. I have to take the y, plug it back into one of my original equations. So I look back to what did my original equation say. So 2x minus 2 times y, but we now know that y is 7. We've already solved for it, is negative 10. So 2x minus 14 equals negative 10. I'm going to add 14 to both sides. Negative 10 plus 14, or 14 minus 10, is going to give me 4. Divide by 2, and I get an x of 2. So for this one, my solution is going to be 2, 7. So again, just remembering the basics of how to tell when to use each method. Now the next two slides are going to be diving into word problems, all right? This is a key feature of this. This is the reason why we teach you a system of equations, so you can solve and interpret these word problems. So let's take a look at this. Suppose you're at the store and want to buy some fruit. Oranges are 80 cents and bananas are 50 cents. You buy 9 total pieces of fruit and pay $6. How many of each fruit did you buy? So using systems of equations, we can solve this equation. So I've kind of broken it down into 3 steps for you to help you. So first of all, I want you to label your variables. What are you being asked to find? So here we want to know how many of each fruit did you buy? So my x and y here are counting the pieces of fruit. So my x, I'm going to have be the number of oranges, and y be the number of bananas. So you always look to the question to determine what your variable is. In this case, the number of oranges, the number of bananas. And you do have to be very specific. Don't put oranges and bananas. You have to put that you're talking about the number of. You're counting how many you're buying. Now, we're going to use those variables to now write our equations. So we need to look to see what information are we given. So let's look at this. I'm going to start with this one. So you buy 9 total pieces of fruit. All right. So there's an important piece of our equations. So if I bought 9 total pieces of fruit, I don't know how many of each I bought, but when I bought so many X's and so many Y's, that total was 9. Well, total means addition. So I don't know how many of each I bought, but that total of those two things was 9. So that's going to be always an important piece, okay? Usually in these problems, you're going to get some kind of total. And so you need to know to add your variables together. Now let's look at the other piece of information that's in here. So oranges are 80 cents. Bananas are 50 cents. And I'm paying $6 total. So that's giving us a money equation. So the first one was a number equation. This next one is the money equation, okay? How much I'm spending. Well, if oranges are 80 cents, to find what you're paying, you always take that cost for one times how many you buy, how many you have. Same thing with the bananas. Each are 50 cents. So I multiply that by the y by 0.5. Again, cost times how many you got, and that's how much you're paying. and it says that that total is $6. So those are going to be the two equations that I'm working with. Now I just have to figure out a method to solve them. Now both are already in standard form, okay? So that's looking pretty promising, having them already in standard form. So that means I'm probably going to use elimination, but I need to see how am I effectively going to use elimination. So again, the tried and true method. Take that x value, multiply this whole thing by 0.8, take this x value of 1, multiply that whole thing by 1. That's how you can get these to perfectly line up. So you'll get 0.8x plus 0.8y equals 9 times 0.8 is 7.2. Then notice this one didn't change at all. So now I've transformed my equations, so now I'm able to eliminate them. Notice my x values are now lining up right. They're the same sign, so I'm going to subtract them. 0.8x minus 0.8x eliminates just like we want it to. 0.8y minus 0.5y is going to leave me with 0.3y. 7.2 minus 6 leaves me with 1.2. And now I divide by 0.3. That's going to give me a y value of 4. So, not quite done yet though. I need to take that and I need to put that back into one of my original equations. So, I'm going to plop it into my original equation. And again, go back to the very original. So just that x plus y equals 9. So x plus y, which we know is 4, is 9. So that means my x is going to be 5. Now, just telling me x is 5 and y is 4 doesn't really solve the question, doesn't really answer the question. The question had a context to it. This was a word problem. That x is representing oranges and that y is representing bananas. So I actually want to go back and answer the context of the problem. So you want to say, I bought 5 oranges and 4 bananas. The question had nothing to do with the x and y. The question had to do with the fruit. So you need to make sure you go back and answer that context of the question. Go back and tell me how much of each fruit you bought. If you just give me x is 5 and y is 4, you're going to lose a half a point or a point on the test because you're not actually answering the context of the question. So let's look at this one. A student has some $1 and $5 bills in his wallet. He has a total of 11 bills that are worth $31. How many of each type of bill does he have? All right, so same thing. First, we're going to label our variables. So let's look at our question. Our question being, how many of each bill does he have? Many is talking about the amount. So my x is going to be number of $1 bills. Y is going to be number of $5 bills. You always want to label your variables because it's going to help you construct your equations. So now that I have that labeled out, now I try to form my equations. I look to see what information is given. He has a total of 11 bills. Okay, so again, that's where I'm going to start because that means I don't know how many x's I have. I don't know how many y's I have, but I know that combined, I know that total, there are 11. Now let's look at the value, the money part. So there are $1 bills, $5 bills, and they total to be $31. So for the $1 bills, so how much they're worth will be what each one is worth times how many I have, just like before when we were talking about the fruit. Same thing with the $5 bills. Each is worth $5, and if I have Y of them, that means total they're worth 5Y. And all together, I have $31. So they're already set up as two standard form equations, which means it's going to be easiest if I solve it using elimination. Now, the cool part of this one is, notice this, my x's are actually already lining up. So this one is actually pretty easy. I don't have to manipulate my equations at all. I can just start by subtracting them. X minus x, it's already gone. I already get to eliminate that variable. Y minus 5y, well 1 minus 5 gives me negative 4. 10, or 11 minus 31 gives me negative 20. When I divide both sides by negative 4, y is going to equal 5. Remember though, that's only half of my answer. I need to go back and I need to find x. So x plus y, which we just found as 5, equals 11. So my x is going to equal 6. Don't forget, don't leave it as just the variables. You need to answer in the context of the question. The question was how many $1 bills and how many $5 bills does he have? So you want to answer. He has 6 $1 bills and 5 $1 bills. You want to answer in the context of the question. Again, if you don't, you are going to lose points on that exam. So, and that is actually all for our notes. I just wanted to expose you to these ideas, and then you'll get to do some practice work to really get good at them. So what I want you to do is write a summary for me. All right, summarize what you got out of this lesson, or if you have any questions left for me, and then come back ready to do your practice work.